So we will start with a few statistics to frame the current situation in the UK. So while 25% of the total carbon emissions of the country are attributable to the built environment, 19% of our footprint is from operational emissions, from energy needed to heat, cool, and power our buildings. So with 80% of the buildings that will be in use in 2050 already standing today, the decarbonation of our existing stock is crucial in order to tackle the climate and biodiversity crisis. However, how this is done is critical to ensure durable and effective results. A new report from the National Audit Office has revealed that 98% of the external wall insulation installed under the government-funded schemes now requires repair or replacement. It is also key to mention that well-insulated buildings support energy security for the occupants, as well as comfort and health, therefore promoting resilient communities. So today we have invited two specialists in retrofitting with natural materials to discuss how to upgrade and insulate existing walls. Insulation is often seen as a simple solution, but when applied incorrectly, it can lead to moisture issues, performance gaps, and long-term building damage. So today we'll take a practical, honest look at how insulation really works in retrofit, with a focus on natural materials, detailing, and real-world outcomes. I'm pleased to introduce Ilias Igomenides, who is Technical Support Engineer at Ecological Building Systems, and Chris Brookman, founder of Back to Earth. Both companies have a fabric-first approach with a focus on sustainable building materials and providing a strong technical support. Our guests are very knowledgeable, so we hope you will find this session useful and informative. Hello, Chris. Hello, Ilias.
Hi.
So here we are.
Thanks for joining.
Thanks for joining us today. So I'll start with what are the benefits of insulating externally or internally a masonry wall. So yeah, let's start with Ilias.
I'll let you go first on that, just because it's the whole start of the seminar.
Thanks, Chris. First of all, I abbreviate external and internal wall insulation EWI and IWI, just to be on the same page, right? Well, as Aurora said, that those statistics are not very good for as results of already done retrofits. So first of all, I would say that implementation on site is the most critical thing, regardless of the specification. But from the building physics point of view, I believe that external wall insulation has some advantages and should be first considered if possible, because, for example, when using external wall insulation, you enclose everything in a warm coat, in a warm jacket. So the whole structure is warmer and the temperatures are overall higher. So basically you insulate, but at the same time you reduce the condensation risk within the structure, within the skin. Now, continuity also is easier, I would say, because when you're insulating internally, you have all the partition walls and all these interruptions. So probably I would say continuity is more easy to be achieved on the external.
It's probably more obvious when it isn't as well, when it isn't made continuous externally, because you can still see it.
Yeah, exactly.
Yeah.
Also, you can be more liberal with the thickness, because the more you insulate, maybe the better it is. So you don't at least increase any risks in terms of moisture, because the dew point moves outwards. So that's safer. So you can go for easier for passive house or other stringent standards. You can combine costs. So if you were to anyway, for example, weatherproof or re-render your cracked render, it's a good opportunity to combine and save some costs by combining both insulation and re-rendering. And also it's a less disruption for the occupants, because everything is done on the outside. So yeah.
Shall I dip in as well?
Yeah, go the other way around.
All of that.
Yes.
All of that. But on the sort of negative side, it's weather facing. So it's actually arguably a lot more critical that all of the junctions are sealed properly, that the external surface is continuous, that people allow cost for moving services. You know, we've all seen pictures of EWI installed around soil pipes or gutter, you know, down pipes or whatever, which is obviously nuts. Moving meter boxes, things like that, or at least bringing meter boxes out. So yes, external wall insulation is a sort of lower risk per se, but again, sort of on to balance that out, there are quite often a lot of services attached to the outside of buildings which do sort of interrupt the continuity of it, and so you know that can be a significant issue as well.
Potentially
anyway,
the detailing under the eaves as well can be tricky.
Yeah, exactly. And I hope this is sort of all
them.
right for everyone, this kind of conversational format as well. Me and Elias will try and make it as more conversational, or as conversational as possible.
I think conversation
but anyway,
is
yeah,
good.
you carry on about IWI.
Yeah, no, yeah, in terms of, in some cases now, of course, you cannot do that on the external because it's either like a listed building or a traditional building with nice stonework, like beautiful features and all that stuff. So you have to go internally. So that's one situation where you could go internally. So you have to.
Exactly, and it's also cheaper. You know, you haven't got scaffolding. You haven't
exactly.
got.
That was,
you can do it room by room. You can do relatively small sections at a time. It's more disruptive, obviously.
Yes. And the access is easier because you don't need scaffolding. Everything is in your level.
But
yeah, I think
you do need people like us to run your woofy simulation.
Well, yeah.
That's the issue with IWI, is that obviously when you externally insulate masonry, you're warming up the masonry, and the masonry stays nice and warm. It's not going to have issues with condensation, assuming you've got continuity, obviously. When you do that internally, you've got to factor in the temperature of the masonry. It's cold, it's getting rain on it, it's got moisture flow from the interior interacting with it. So whilst it's sort of a simpler build-up or a simpler installation, the assessment of it is rather more important, and certainly the assessment is an awful lot more complicated and a lot more complex. External insulation you can do with pretty much a simple condensation risk analysis, but internal insulation obviously requires
so I think
analysis.
I'm going to jump on to the next question then, which is, well, when we're doing internal insulation, so that we are pushing the dew point a bit further into a structure. So how much insulation can be added internally as a rule of thumb without having to run a woofy calculation, without running the model?
Shall I start with that one? So we would quite happily put 20 mil and in most places 40 mil without having to worry about it. Beyond that, you start getting nuances in masonry type, in location. So London and the southeast, well, particularly London, it is quite an easy place to insulate. You can actually put quite a lot of insulation on there, and you can most of the time be pretty confident that it's going to be okay. Sort of 60, 80 mil. Once you're up to 80 mil and beyond, you really should be looking at woofy analysis. Natural stone is much more challenging than brickwork, and so beyond 40 mil pretty much anywhere, if we were putting on 60 mil IWI onto natural stone, we would want to be modeling that.
Why is that? Is that due to the porosity of the brick compared to the stone?
Yeah, well, it's the porosity of the surface. So you've obviously got lots of individual stones with mortar around them. You've got an enormous area with which to let water into the wall. The joints can be quite big, and so the whole surface is quite porous. The conductivity of the stone tends to be an awful lot higher than brick. I don't know off the top of my head many stones other than something like pumice, which would be less than brick. The thickness of the wall makes a difference, the amount of moisture that it can hold. So there's a load of variables which change that. So yeah, certainly natural stone is more challenging. So on balance, I would say 20 or 40 mil pretty much on anything is going to be okay, but anything above that, and as you move further north and west, you really should be getting some proper analysis done.
Okay.
What do you reckon, Ian?
Just to add to that, just one sentence. We even, I mean, using mineral-based or capillary active insulation would be, on the safe side of the things, especially when you have a little bit more exposed facade. So I think the exposure as well should be taken into account, even at thin, like maybe 30, 40 millimeters. Again, we should account for that as well, especially when we're using bio-based like wood fiber or hemp or that type of insulation.
That is a good point. I mean, we quite often move over to mineral-based insulation on natural stone when people want to get a sort of a relatively low U value, simply because wood fiber is a great material, but it can't do everything, and so we need to use mineral insulation sometimes just because they can cope with higher moisture levels, really.
Okay, so staying on the internal wall insulation topic, there has been some conversation around whether we should leave a gap between the insulation and the masonry behind. What's your take on that, and what is the science saying?
Should I go for that first, please?
Go on then. I'll let you run with that one.
Yeah. Oh, thanks. That's a pleasure. Look, yeah. I mean, from all the literature and from experience, we would prefer to have a fully attached or fully bonded insulation against the existing brick or stone. And if there is a case where we have the option to allow for a gap, this gap, we have to make sure that it's well ventilated. I mean, we wouldn't go for a gap between the existing wall and our insulation if that gap is not very well ventilated. That's a tiny pocket of high humidity, high relative humidity, very cold surfaces, and that's a perfect combination for potential failure there. So yeah, either fully bond or attach your insulation, or allow for a gap, probably with well ventilated strategy.
Okay.
And because there was this chat on the ACAN chat the other day. So in theory, if you have an insulated wall and you have a cavity and then you have all the masonry on the outside of it, as long as you can externally ventilate that cavity and ventilate it well, then yes, that's great. That doesn't take into account what's going on with joist ends and beam ends and even rafter feet and that kind of thing. So on paper, there is this, I think anyway, this kind of thought that having a cavity between the insulation, as long as you can ventilate that cavity well to the exterior, that's going to be the best solution. I don't think it's practical, because I think it's nigh on impossible to effectively get enough air passages through the wall at low level and high level to actually create enough airflow. The thing that is often not considered is what the masonry is doing as well. If you've got a stone wall that's relatively cold and probably quite wet on the leeward face, that's dumping a load of moisture into the cavity as well, which has got to be ventilated out. So it's not just any sort of moisture that's getting through the internal insulation. There's so many other things going on. So we would generally say, exactly as you say, Ilias, fully bond, because then you're eliminating voids that can grow mold either in the insulation or within the structure elsewhere, which will affect the insulation and timber. You've probably got a better handle on what's going to happen to joist ends and things like that as well. So again, we would very rarely say it's a good idea to introduce a cavity between the two, unless you're really confident that you can ventilate it and you don't have joist ends and things bedded in the external wall.
And so
a realistic example could be like an old barn that is 1 story high, and you can easily have like an open cavity at the top, and some grills and enable the air movement there. But other than that, I think everything else is very, very challenging and probably not recommended.
So the fully bond means that if there's a bit of moisture happening on that surface, it's being wicked back into the building later on. Is that what that does as well with the, or not necessarily?
It's stored in lots of different ways. So some of it will be stored as vapor, some of it ideally wouldn't be stored as liquid moisture, but potentially could be certainly the outer parts of the wall. It probably would be stored as liquid water potentially. At the interface between the insulation and the wall, that shouldn't be liquid water. It should be stored as vapor.
Okay.
So yeah.
Yeah, so you have to identify first what's the source of that moisture. Is it like liquid, like a bulk ingress from the outside, from a crack, or from chimneys, pouring down? Or yeah, if that's the case, that should be addressed first. Everything should be weatherproof, dried out as much as possible, and then go ahead with your insulation. You could trust any high amount of moisture existing there.
Okay. What about cavity wall? Can we fill them, or when can we fill them?
Is that? I'll jump in with that one.
Yeah.
So cavities are there for a reason. They are there to effectively provide a rain screen for the inner surfaces. So they do something. We, as a sort of a general rule, without individually assessing each project, we would normally say don't fill the cavity unless you're going to be putting external wall insulation on the property. Basically, because if you fill the cavity, you are providing a moisture path from the exterior of the building towards the interior. And okay, whilst that's more of an issue if you've got any timber bedded in the walls, but equally, moisture getting through to the inner leaf of the masonry is not ideal, and can cause issues with mold growth and everything on the interior, which is often what's seen in cavity-filled buildings. So we try, and recommend that people don't fill it unless you are creating another external surface that is insulated, so the dew point is outside the cavity and it's preventing any sort of rain ingress as well. I'll let you jump in now.
Just to add to that, because in some cases the cavity is not fillable because it may be very small, or may have debris, or it's not like adequate situations for filling that in. But if you insulate externally, you'll have to somehow seal that, because if you have air bypassing, like cold air bypassing your insulation getting in the cavity, then basically your external insulation is redundant. So at least you can air seal the cavity before insulating externally, if it's not possible to fill that in as Chris suggests.
Okay. So we either need to keep the cavity if we are internally insulating, or if we externally insulate, we need to make sure that cavity is either filled or totally sealed.
Exactly that. There are cases where you can internally insulate, but as a general rule, I would say don't do it unless you've had a fairly detailed analysis. So yeah, again, it's sort of location dependent, it's masonry type dependent, it's surface dependent. So if it's faced brick, that's not going to be anywhere near as weather resistant as render. So there's a load of sort of caveats with that. So yeah, as a general rule, don't do it. But in individual instances, sometimes it is quite possible. I know you guys do recommend that from time to time, don't you, Elias?
Yeah. Carefully, but we do. Yeah. If that's the case, look, the external leaf of the cavity is a very good protection against any moisture that comes through. So cavity wall, actually, if unfilled, it's the best case scenario for internal wall insulation, I should say.
Absolutely.
Okay. So while we are just touching back onto the internal, well, actually on both, how much insulation makes a difference? Because sometimes we are quite restricted by space, and does it make sense to put 20 mil of insulation on the wall, or it doesn't make any difference? There's no point doing it. What's your opinion on that?
Yeah, I can start with that. That's fine, Chris. Yeah, so I have that diagram here that shows. So basically, this
I'm loving my
I think we've got it.
I'm jumping in. I'm diving. So basically, this diagram shows, how effective the first centimeters of the insulation is, and I have just a natural insulation here example. So an uninsulated wall starts off probably around 2.1, 2.2. Right, and with 25 millimeters, it goes down to 0.88 U value straight away. So you see how effective is the first portion of the insulation, and then it starts flattening out. That means that even if you apply 20 or 30 millimeters, you're going to significantly improve the situation, the heat loss, as well as the surface temperatures, right? Now, of course, it's a shame if you do that, not to apply a little bit more, because that's once in a lifetime that you're going to do that. But nevertheless, even if you apply, I don't know, that's why also we say the sweet spot is around maybe 60 to 80 millimeters. If you see that graph there, from that point and beyond, it starts flattening really. So unless you go for Enerfit or any other standard, you need to hit, a specific, like a specific targets. Maybe 60 to 80 millimeters is a good starting point. And then, of course, you have to do the hydrothermal modeling and everything to make sure that that works. But yeah, and just to add to that, maybe 20 millimeters is a good amount of insulation for all the detailing, because if you allow for any interruptions in your insulation, if you allow for no insulation in the window reveals or any shutter boxes, any whatever intermediate floor junctions, even if you can allow for the same amount of insulation you use on the wall, maybe you use 80 millimeters on the wall, but you cannot return that to your window reveal. Even if you apply 15, 20, 25 millimeters, okay, that's not gonna be ideal, but it's going to be improving hugely the effects from the cold bridging around the window reveals or all the detailing. So continuity is more important than the actual thickness of the insulation. That's the bottom line.
And
kind of back that up as well.
Is that felt the same way if you apply 20 mil internally or externally, or is it that is more efficient internally?
That does make a big difference.
Yeah.
Sorry, Elise.
No, but go ahead. Yeah, I talked too much about that.
No, it's fine. As long as we've got our answer.
That makes a big difference. So the sort of absorptivity of the surface in terms of the sort of infrared radiation, having a very thin layer of insulation on the surface insulates you from the masonry. Masonry absorbs infrared radiation very, very quickly. And you can actually feel through your skin. Your skin is full of thermoreceptors. You can actually feel the sort of the cold of the wall almost. Putting a 20 mil layer, as Ilya says, you're raising the surface temperature, so you've isolated yourself from a cold surface. But yeah, you instantly feel a big change in comfort just with that first 20 mil. If you put that 20 mil on the outside, you're not isolating yourself from the masonry. Your overall U value might be lowered, but you've still got what is effectively pretty cold masonry next to you. And that goes for external wall insulation generally. To get the same sort of boost in comfort, I mean, it's kind of anecdotal, but you normally need best part of twice as much insulation externally to give you the same boost in comfort as internal insulation. So yeah, it does make a big difference where you put it.
That's quite important.
U value, that's a good distinction, Chris. So the U value may be the same. So the steady state of the heat loss potential is the same, but the dynamics change. So thermal mass plays a role, and moisture and radiation effects between the bodies, and as Chris says, and the elements. So yeah,
and it's not to do with just the temperature of it either. It's to do with the interplay between your body and the wall.
Because you may be the radiator for your wall if the wall is cold, basically. So you radiate the other way around.
Exactly, and that's why you don't feel so comfortable.
That is great. We was wondering, maybe the graph you've got behind you, Elias, would you be able to post it in the chat? That's for internal wall insulation, isn't it? Or I mean, great. Yeah. So it'd be great. I'm sure you, the audience, will appreciate that. So next topic is about wondering whether some materials are better for internally insulating riskier walls. So thinking of lower ground floors and things like that. Don't know who wants to start on that one.
I mean, I can start with that as well. Yeah, the as we sort of said just now, we tend to move over to mineral based. Ilias has got the calcium silicate boards. We've got a product called Multipore, which is again a foamed lime, sand, and cement board. these products are really vapor permeable. They're quite capillary active, but they they can tolerate much higher moisture levels. So when you're working with stonework, which is really conductive or really porous, that's going to be quite wet, they're a great material to use. If you're working underground where the masonry is going to be damp all the time, you can use it in that sort of location as well. There are salt retaining plasters and tanking plasters that you can use with it. So you're not getting necessarily vapor permeability, but or particularly not if you use a tanking membrane. You don't really want loads of moisture coming through your wall into your building, obviously. So that's not necessarily too much of an issue. The capillary transport of the boards is really important because that's moving any liquid moisture around. But yeah, these kind of mineral boards are what we would generally default to in those kind of situations.
Yeah, same here. And another benefit usually of this lime-based or calcium silicate boards is that they have high pH, so they are basically inhibiting mold as well. So that's another, and they are non-combustible. So if, in some cases that's a mandatory requirement. So
that's actually another useful point. Actually, so they can be used all the
way
up.
But yeah, that's another benefit of using those in some cases.
Yeah. Another risky location actually when we insulate externally is the level under the DPC. So basically under 150 millimeter from ground level. What do you recommend using there? Because natural bio-based materials are not suitable, I understand.
You go, Elias.
Okay, yeah. So if less, I mean, there are materials available in the market. I know most people don't like, or some people don't like them, or we don't like them. Anyway, there are materials that could be used in this case below DPC level, like glass foam blocks or recycled glass foam aggregates. So the glass foam blocks that can be also structural, could be literally instead of a layer of a brick, use that around the perimeter, or if you could fulfill around your foundations. Again, that's structural, subject to structural engineers, findings there, or consultancy, how deep you can dig. But yeah, if you are able to allow maybe for 20, 30, 40 centimeters of glass foam internally, and then on the top of that a lime-based screed. Also, if you could do that externally as French drain, fulfilling with glass foam aggregate. Glass foam aggregate is inert to water basically, so you create that capillary break between your the ground and your structure, but it's also insulating, so you can also reduce the thermal bridging around the perimeter by doing that. So I think, yeah, at that risky area, if you want to improve the thermal bridging and
I'm going to blaspheme and say we use. Oh, sorry. I was going to say I'm going to blaspheme and say that we use XPS quite often at plinth level. From a pragmatic point of view, it's sort of readily available. It's chemically inert. It's inert to moisture. I appreciate it's polystyrene, so obviously you want to use it sparingly, or in many cases ideally not at all. But that would be the default. The multi-pore boards that I mentioned, they also do a version that you can use externally as a plinth. So it would be a mineral board rendered, as you can see, and hopefully in this image, sort of tapered. Oh, my fingers disappeared. Tapered, as you can see in that image. So yeah, there are other alternatives. As with everything, though, anything that sort of deviates from the mainstream tends to be more expensive. So the multi-pore is much more expensive than Styrodor, but at least you're not getting microplastics when you're cutting it, and
multi-pore being the foam glass panel, right?
Multi-pore is the lime, sand, and cement foamed board that we do. So no, it's not foam glass.
Okay. Could you use foam glass in that
yeah, absolutely. Yeah. As Elias was saying, you can use foam glass
as a board on the base of your wall, basically.
Yeah, absolutely. The nice thing about the multi-pore is that it is still vapor permeable. So there's more option for the base of the wall to dry outwards. Foam glass blocks aren't vapor permeable, so yeah, this would be again in specific instances you might use the multiple.
Okay, and why is the insulation tapered at the bottom of your
it allows
image?
the rendered surface to come down sort of down the surface of the board and then back to the wall, so you don't get capillary transport of moisture up the back of the board.
Great.
Yeah,
good.
That's what it's for.
Thanks. Yeah, so talking of materials, are them like bio-based materials then more suitable for internal wall insulation and others for external, or can they be swapped around? What do you, maybe that's one for Elias.
Yeah, you can use bio-based materials externally. Now, a few caveats there. I wouldn't use like a calcium silicate board externally, for example, but you can use a lime insulating plaster. You can use diathanite externally. You can use wood fiber externally, of course. Now, the thing is that if the areas of your property is very exposed, we would preferably want to have the insulation exposed to the weather with a direct render. So we would preferably button out, create like a ventilated void, and then a render board, and use preferred finish on the top of that. Of course, if you are in different, like more sheltered area, that could be safer. But especially with the with the wood fiber, the bio-based ones, you don't want to have any micro cracks and leaks there, because it's you don't want them to stay saturated for long. And these have been the cases, some cases in the past we've seen. Anyway, that's what we recommend. Always, of course, it's preferable to have vapor open insulation, that being on the inside or the outside, because if you use it on the outside, most of the drying anyway during the year is to the outside, so that's a huge benefit. If your wall is even slightly damp, that's going to keep drying. And of course, we know the benefit of using vapor open insulation on the inside, because the back diffusion, again, the drying to the inside is very important in this case. So yeah, I would say you can use the materials externally and internally, but externally in some very exposed locations, I would
extra protection over.
Extra protection, yeah. And of course, all the detailing, walls to, as Chris said before, wall to ground, or you need special attention because these materials, you don't want them to be saturated. So Chris.
Absolutely. And yeah, I mean, all of those points, we supply wood fiber primarily for most insulation applications because of the properties that it's got, the thermal mass that it has, the moisture management that it has, the vapor permeability is one thing. We specify it because of its properties, not because it's sustainable and everything else. It happens to be sustainable. It happens to be, low body energy, low, that's a good way of locking up carbon, all these kind of things. But primarily, it's an extremely useful material. You can't use it everywhere, which is why we supplement, the plinth or anything below ground, or whatever. But the main bulk of the insulation that we use and specify is wood fiber.
Okay.
So it is a good all-rounder.
Talking of failures, I think we need to look into that now. In your experience, where insulation tends to fail and why, and how can that be avoided?
Can I start with stupidity? Is that allowable?
Yeah.
Who thought that was a good idea? Oh, look, the windowsill's not quite long enough. I'll be fine. So it's junctions. It's always junctions. And I appreciate, Ilias, that you guys don't promote sort of direct render. We do generally promote direct render, arguably not in really exposed locations. We would tend to default to a render board over the top, but it's always the junction. So it's sill details are our biggest burden. We've had to come up with very specific details to make sure that people A, pay attention to it, and B, don't get issues with it. A lot of window manufacturers, they give you a sill section and a jamb section. There's no idea of what you're supposed to do in the corners with their sills, and quite often their sills are literally just like this, are just folded bits of aluminium or whatever, with no thought about how you actually seal it to anything. The other one that I was just going to highlight is, other junctions like this daft one where there's an upstand on the coping on the wall, and they've just rendered it over, and funnily enough, over time it's just popped out of the wall, so they put silicon on it. Just making sure the detailing and the junctions with your external surfaces is what it's all about, making them continuous and making sure that there's sort of robust weather-tight detailing.
Yeah, 100% detailing. I have a couple of pictures here of bad detailing. That's not even a junction. The boards are not even in touch, or like weak cross joints like this one the board should be properly staggered, or things that we see in the brochures but people don't follow. So overseeing the things on site it is very important, or workmanship basically is very important, except for detailing like desk.
And internally, I guess, I mean, we're looking at external ones here because they tend to be more common. Internally, again, it's always workmanship, but again, it's about making sure that you've got full contact. Assuming you're using fully bonded system, you've got full contact with the wall, and all the air tightness detailing is done correctly. Because if you've got a great big hole in your air tightness layer and you've got loads of warm, moist air dumping moisture in your fabric, that will create a wet point, and which will affect your insulation. So with any intervention, it needs to be done properly. It's not specific to wood fiber or natural fiber. It just, whenever you insulate a building in any way, it should be done fully and properly.
And making sure there are no thermal bridging, so window reveals and shutter boxes and all this.
That's for all you architects to design.
Yeah.
That was me.
No comment on that.
So when we're looking at insulating, and surely the aspect, whether the elevation is due south or north, makes a difference, especially in insulating externally. Is there something we need to consider at that point?
Yeah, I mean, when with external insulation, you generally work out which is the most onerous face, and you would repeat the specification for all the other walls. So if you're in an extremely exposed location, you might use wood fiber boards with a counterbatten and then render board and render on top of that. Or if it was more sheltered, you might just use direct render, but that would be replicated for all the other elevations. When you're doing internal insulation, WUFI allows you to assess 8 different orientations, so south, southwest, west, etc. And again, in using that methodology, you find which is the most onerous orientation for weather, you find which is the most onerous orientation for temperature, so which is normally the north, and you create specifications for those elevations, and then usually the specification is carried over onto the other faces and works more effectively.
Okay, we actually have a lot of questions in the chat, and there's one that is where can we find people to do WUFI calculations? Who do we turn to?
I'll let you start with that one.
Look, we do WUFI calculations for all the specifications that refer to our materials. So we can do that. Of course, Chris does that as well. But there are consultants out there that you can refer to for that purpose. So there are a few specialists that do that as well. So
I mean, so for us suppliers, we would tend to be doing an internal WUFI simulation for a specification, because we're going to stand behind a specification. It's our own due diligence that we're doing the WUFI simulation to make sure that what we're telling the customer is correct and is not going to have any issues. That would be different to going to a consultant and saying, can I have a WUFI report on this wall? Because they would give you, they would choose, I guess, various different insulation options, and they might tell you which one is the best, but they would also produce a fairly detailed report of the whole thing, which would obviously come with a cost. But you know, us and Ecological, we do detailed internal assessments, but we don't then produce a great big report to give to the customer.
Okay. Now that we've done our insulation on the walls, how can we finish it? Is that, what type of finish can we apply on internal wall insulation, for example? Are there anything we should ban?
There's lots of different things you can use. I mean, we have either a direct plastered internal insulation system where you're using lime plasters, and basically you would use generally lime to directly plaster onto wood fibre. We do a counterbattened then plasterboarded system. So plasterboard is again very vapor permeable, or Thermacell also, you know, equally permeable. So there's quite a lot of different finishes, and then, you know, you'd put a gypsum skim on that. You generally wouldn't gypsum skim directly onto wood fibre. The gypsum goes off too quickly. It doesn't really bond that well to wood fibre necessarily without any primer. And also it's very difficult to get a mesh into it to reinforce it. So it would tend to, you know, without a mesh, it would tend to crack across the joints. So yeah, basically you'd be looking at direct lime plaster, overboarding with plasterboard, maybe some ply finishes over a counterbatten as well.
Yeah, I agree with Chris. It's important for the materials to be vapor open, and especially for the paints, because in some cases you get all the specification right, and then someone paints over with the plastic paint. And also breathability is not like binary. It's not it is or it is not breathable. It is a spectrum. So I would make sure that I get the figures for the vapor diffusion factor, or the vapor permeability of the material of the paint from the manufacturer, and make sure that it's suitable, because even also the thickness plays a role. If you put like 2 layers of a paint, it's different to putting like 4 layers of a paint, because it doubles up the vapor resistance.
Yeah.
So it is, so that's maybe subtle, but it's it's critical. And another way for finishing, we find it like common in more commercial or hotels, that type of buildings, is like using your insulation and then buttoning out, using a board like maybe a wood wool board type of board, or clay board, and then plastering over that, or maybe using in this case a wallpaper, making sure that the service void is enabling air movement to the inside though. So basically you decouple completely your finish from your actual performing section of the wall, and then you have more freedom to use like finishes on the inside, because that's a pain point for architects or for decorators, basically wallpapers and these materials that need to be used in some cases in more
that brings me to my next question. What about if I need to tile that wall that I've just insulated? Typically in bathrooms.
So exactly as Ilias was saying, you would decouple the internal surface from the insulation. The service void here that you can see in between the battens would be internally ventilated, and that would allow it sort of very slow, but it would allow diffusion in and out of the wall, independently of having a tiled finish. You can directly tile onto wood fibre in small areas as sort of splashbacks, but if you're doing a sort of a wet area behind a shower or something, within a shower cubicle, you would generally not want to direct tile onto the wood fibre, because the risk of leaking through all that would be enormous. So
okay, so the risk is more about the leak from inside from the shower rather than
I mean, it obviously tiling big areas of wall directly doesn't allow or it massively reduces the moisture flow in and out of the wall if you're tiling directly onto the wood fibre. The lime-based base coat and the mesh base coat that goes over the wood fibre is strong enough to take a tile, but the vapor resistance of tiles is pretty high. So like I said, you might do a splashback or a little strip around a bath or something, but ideally you wouldn't do great big panels. And as I say, in a shower, showers always leak. It's just a case of time. So yeah, you would try and decouple that and install a surface void, as you can see there.
Actually, going back to the brick itself, I'm just thinking, when we are insulating in an existing building, and most of the time walls are already plastered or have finishes, do we need to remove them all before we install insulation? Can be the same for externally. If we've got a render, can we insulate on top, or do we need to hack off and go back to brick?
Do you want to do that one, Elias?
Yeah, especially, not especially, but overall internal or external application. I mean, the first thing we have to consider is preparing the wall properly. That's the major factor of the success. Making sure there is no water ingress from the outside if it's internal insulation. There is no stored moisture. So addressing everything that contributes to the moisture load of the structure, that's very important. Then assessing if there are any salts coming through, because it's a different type of addressing that issue as well. What type of existing plasters are in place? Is it gypsum? Is it cement? Is it lime? That being on the inside or the outside, that needs to be removed, or you can keep it in place. So it's an overall like step-by-step process you should follow. Basically, we should follow before even considering anything on the inside or the outside. And yeah, actually we've drafted a document, and we've written a blog. You can find it on the website. That may be a good guidance.
Maybe you can drop the link in here. That would be useful.
Yeah, I can do that.
I have to say as well, like 3D models, as per the one behind Chris, are really useful to understand build-ups. Sometimes better than photographs.
That one's on
that's on your website.
Yeah.
Maybe we should put the two links on the chat.
Sort of in addition to that, we try and retain existing plasters first of all, because obviously there's an energy cost, well, a physical cost and an energy cost to removing a plaster. Obviously, if you're stripping off a load of plaster and then bringing a load of lime or whatever that's uses a lot of energy to create it, that's not ideal if you can retain the existing plaster. So, we would find out what the existing plaster is. If we're talking about internal insulation, we would try and model it and see if it will work. So with a cement plaster is fine. Gypsum plaster can work in some instances. It's very, very limiting. I know I'm a bit of an outlier in saying that, but there are some instances where it works. And so we do try and keep it in those instances. And then, obviously the internal insulation over that. When you're doing it externally, again, we're pretty relaxed about retaining cement plasters. If the wall's sopping wet, then that's a different scenario. But if the wall is in generally good order and it's got a cement render on the outside, even if it's got masonry paint on it, there's very little point in trying to rip all that off. The external insulation, will keep the building warm. The moisture issues will be pretty minimal if there are any at all. The only issue is if you get leaks in that wall, it's obviously much more difficult to dry out. But yeah, our primary goal is to retain existing plasters.
Okay.
Or renders.
I've got one final question before we actually get to the chat questions. We won't have time for many of them. So if your questions are not being answered today, they will be answered by text by the speakers, and we will collate the answers and we will send to everyone after the session alongside with the recording and the images from the speakers. So my last question was, is there anything else we need to consider when we do insulate a building? Just thinking ventilation. Anything else? And what? Yeah, basically a more holistic approach.
If you want to breathe, ventilation's not a bad one.
Yeah.
Yeah, I mean, you have to assess it as a whole. I mean, ventilation is absolutely critical. You need obviously enough ventilation for decent air exchange, just for good air quality, but you also need it to keep relative humidity down, because relative humidity, particularly if you're insulating your walls internally, has a big impact. If your walls are uninsulated, it also has a big impact, because obviously the surfaces are cold and you can drop a lot of moisture onto it. So yeah, ventilation is absolutely critical when you're considering insulation. Full stop, really.
Okay.
Yes.
Yeah, no, I agree 100% because that's the missing point. In most of the cases, you insulate. Inevitably, your building is more airtight. Either you target for airtight building or not, and then, as you said, relative humidity goes up. And yeah, opening the windows, you should be very diligent. I mean, maybe 2-3 hours a day opening the windows can do the job, but who does that? You need a proper ventilation strategy in most of the cases.
Yeah.
That's an important point, actually. It's a strategy. It doesn't have to be a ventilation system. It doesn't have to be MVHR. You just need to have a decent strategy and a realistic strategy that doesn't involve one trickle vent in one window in one room.
Yeah. No, we know that doesn't work.
No.
Great. Thank you for all that. We've got 6 minutes to go over a few questions from the chat, and we'll try to make the answers short if possible. The first one is back on the WUFI calc, and it seems that a few people say that there's a general rule of thumb that we shouldn't go over 35 mil of insulation before needing a WUFI calc. Is that something you agree with?
There or thereabouts.
There is no, I mean, there is no very exposed location. There is no high humidity on the inside. I mean, so the boundary conditions as well should be considered before just across the board saying that it's fine, in my opinion. I think we always should be on the conservative side of the things, that being the specification or the calculation themselves.
The next question is from Dominic regarding with biological solution more generally, which I'm thinking is probably bio-based materials. Do we need to be aware of, is there anything we need to be aware of with changing climate, thinking of floods and rising
floods
levels?
Is an interesting one, actually, because people often say, oh, what if, if my house floods, using some sort of bio-based material is going to be a problem. If your house floods, it's not the water that is the issue, it's all the stuff that's in the water that is the issue. So irrespective of whatever insulation you've got, you're going to want to pull it off. Flooding doesn't make any difference, other than obviously you've got probably higher moisture levels at the bottom of the wall. I think realistically, as time goes on, there needs to be better assessment of individual projects, particularly for internal wall insulation, with any insulation material. Because as I say, in London, you don't always have to use bio-based materials. There are plenty of instances where mineral wool or other materials can actually be used. We obviously promote wood fibre because it's an extremely good material and everything else, but it's not unique in being able to insulate in certain instances.
You want to add anything, Elias? Or
100%. I agree with Chris. Yeah.
Question from Lucy, who asks whether we could use cork externally. I know it's been done. What's your take on cork?
Yeah, cork boards can be used externally, like as you could use the wood fiber, for example. Could be a little bit less absorptive, or less risky, I should say. I would still not trust a direct render in exposed climates. So I would again suggest buttoning out and using
having some sort of cladding over.
But they can be used. Cork boards can be used externally, no problem. Yeah.
Okay. And follow-up question on that is that how do you deal with the junction between the natural materials and the oil-based material below? Or
pretty simple. It's usually just a case of some sort of adhesive, be it the plaster that you're using, because most of the plasters that most of the renders that you put on the surface of any of these products are called contact mortars. They kind of glue things together as well. So yeah, the detailing is actually very, very simple.
Okay. Maybe the last questions from Dominic. His concern on internal wall insulation is always the choice ends, and is there now good evidence on a robust detail that can refer to for breathable solution? Yes, I see taping. Go on, Chris.
That's so when we're running WUFI models, we are looking at the inner sort of 100 mil or so of the masonry and looking at the relative humidity in that area as a proxy to see what the likely moisture content of joist ends will be. In terms of the practicality of it, as you might be able to sort of see there, this is our nature wall system, so it contains a membrane. Membrane or not, you would usually tape around joist ends like that, and then if it was direct plaster, you'd plaster over the tape. With this, obviously, there's batten layer and more insulation, everything that goes over the top. So joist ends aren't necessarily a problem, but they definitely do need to be considered.
Okay. Well, thank you. Elias, you've got anything to add? No, I think
No, I agree with Chris. I mean, making sure that junction is airtight by using either tape or a liquid applied sealant, which is maybe easier, brush it around, and then plaster over with lime-based. We use diaphanite. It's lime-based materials can also create an alkaline environment, again, inhibiting to mold, and also because they're capillary active, they pull the moisture off the timber as much as possible. It's not the perfect detail, but I think that's the only realistic approach.
Okay. I think we're going to have to wrap up, but I have to say on both your websites, there are quite a lot of details available. And
Aurora, I couldn't share because the graph is not on the website. I couldn't share that in the box. But,
we'll find a way to get it to all the attendees. And yeah, I was telling the participant that it can go on your website, and there's also the ACAN natural materials details. That is quite a good resource, and so we hope that you found today quite informative. I mean, I certainly did, and I learned. I see Anna is posting quite a lot of links to website on the chat, so I think that's it. I'm going to say thank you to you both. That was
thank you.
Great. Thank you for joining us today, and thank you to all the attendees. It's great to see all of you there. And so that was series 2. There will be another one soon, I hope. Thank you, everyone.
Thanks a lot.
And bye.
Bye.